So good day. In today's class, we are going to be looking at solution to practice questions. So the first question says, a bag of apples weighs 7 kg, that's 7 kilogram, correct to the nearest kilogram. What is the least possible weight of the bag of apples? From the question number one, that says a bag of apples weighs 7 kg. So the weight of that is the weight is 7 kilogram. Correct to the nearest kilogram, what is the least possible weight of the bag of apples? So in this type of question, we are going to have two possible weights different from this, that is the lower limit of the weight given and the upper limit of the weight given, where the lower limit will be the least possible weight. And to get that, we are going to consider the unit value given to us. So we are asked to correct if this 7 kg is correct to the nearest centimeter. We are going to have two limits, that is the lower limit and the upper limit. So to have the lower limit, so we are going to consider the unit given, that is the unit we are correcting to, which is to the nearest kilogram. So nearest kilogram in this case, so the limit is to the nearest kg. Nearest kg means 1 kg. So 1 kg, since we are dealing with two limits, that is the lower limit and the upper limit. So that is why we are going to have lower limit. Okay, lower limit will now be 1 kg all over 2, which is 0.5 kg. So this is the limit, that is the 0.5 kg. Then to now know the lower limit, is going to be lower limit, which is equals to 7 kg minus 0.5 kg. So 7 kg minus 0.5 kg gives us 6.5 kg. So this is the least possible weight of the lower limit. Then in this case, you might have to find the upper limit, which is the greatest possible weight. So the greatest possible weight, which is the upper limit, equals to 7 kg plus 0.5 kg. So which is equal to 7.5 kg. But if you look at question one says the least possible weight of the bag of apple. So we go for 6.5 kg, which is option B. So that is that on question number one. Then we move to question number two. So question two says the speed of a car is 50 mph. So the speed of a car, that is the speed given, is 50 mph. So in the case of this one too, we are going to look for the limit. And here we are correcting to the nearest 10 mph. So nearest 10 mph, so the limit will be 10 mph. So 10 mph divided by 2. Why do we divide by 2? Because of the two bands we are going to have. So we have the lower band and the upper band, which is also known as lower limit or the upper limit. So here we have 5 mph. So this is our limit. Then lower limit will be the speed given, that is 50 mph plus 5, minus 5 mph. So which is 45 mph. That is lower limit. Then the upper limit equals to 50 mph plus 5 mph. So which is equals to 55 mph. So if you check the question says rather the least possible speed of the car. So the least possible speed of the car is known as the lower limit of the car. So the lower limit is 45 mph, which is option B. So we go to the third question, number 3. So question 3 says, the speed of the car is 50 mph, correct to the nearest 10 mph. What is the greatest possible speed of the car? So we are going to get this from question number 2. If you check question number 2, we have to find the least possible speed of the car, which is 45 mph. Then the greatest, which is question number 3, that is the greatest possible speed of the car is equals to 55 mph. I think this one is clear to us because from number 2, if you check question number 2 and question number 3, we have the same question there, the same information but different question. And the question is from number 2 we are asked to find the least. For question number 3 we are asked to find the greatest possible. So the greatest possible is also known as the upper limit of the speed of the car. That is question number 3. Then number 4. So question 4 says the distance between the sun and earth is 150 million kilometers. Correct to two significant figures, write down the lower part. So number 4. So the distance between the earth and between the sun and the earth is 150 kilometers. 150 million kilometers. So correct to two significant figures, write down the lower bound. So what is the distance? So the distance is given as 150 million kilometers. So in this case, we are asked to correct to two significant figures. So two significant figures will be the lower limit, the limit two significant 1, 2, that is so divide by 2. So if we divide this by 2, we have 50. That's 5 million kilometers. So 5 million kilometers, if you look for the lower limit, which is the lower band of what we are looking for, write down the lower band. So the lower band will be 150 million 150 million minus okay, we have 5 million. So we have 0, 0, 0, 0, 0, 0. Then we have 10. We are left with 4. That is 5, 4, 1, which is 1.5 million kilometers. So the lower band is 145 million kilometers. So that is the lower band for this question number 4. So the answer is option D. The answer is option D. So that is that for the 4th question. So let's move to the 5th. So question 5 says the distance between the sun and the earth is 150 million kilometers. So correct to two significant figures. What is the upper band? What is the upper bound of the distance between the sun and the earth? So if you check question 4 and 5, they have the same information but with different questions. So what we are going to use, we are going to use the limit from question 4. And what's the limit then? The limit is 5 million kilometers. So the limit is 5 million kilometers. And since we are looking for the upper bound, which is the upper limit, so upper bound will now be upper bound will now be equal to 150 million plus 5 million plus 5 million kilometers. So we have this. So it's 0, 0, 0, 0, 0, 0, then 5, 5, 1. So the answer is 155 million kilometers. That is option B. So that is that for question 5. Then we move to question 6. Question 6 says Muhammad measured the length and width of a rectangle. So he measured the length to be 18 centimeter correct to the nearest centimeter. So number 6, the length measured by Muhammad, so length is given as 18 centimeter. But when this length is corrected to what? Nearest centimeter, it's now, I'm going to use small letter L for this. So let's use capital letter L for the actual length. Then when correct to nearest centimeter, we have length small letter L, which is nearest centimeter will be a centimeter is 1, so 1 all over 2, that is 18 plus or minus 1 over 2 centimeter, which is 18 plus 0.5 centimeter. So which is 18 plus or minus 0.5. So we have plus, we have equals to 18 plus 0.5 centimeter or 18 minus 0.5 centimeter. So which is 18.5 centimeter, which is the upper bound, or 17.5 centimeter, which is the lower bound of the length. Then for the second, for the width, measure the width to be 10 centimeter. So the width, the actual width is 10 centimeter. So I use capital letter W, which is equal to 10 centimeter. Then the estimated width, that is small letter W, equals to, so that one too is also connected to nearest 10 centimeter. So nearest 10 centimeter is going to be the actual width, which is 10, plus or minus the unit we are connecting to, that is nearest 10 over 2 a centimeter, which is equals to 10 plus or minus 5 centimeter. So we have 10 plus 5 centimeter or 10 minus 5 centimeter. So here we have 15. Now that W is 15 centimeter or 5 centimeter. So, or 5 centimeter. So the question now says, calculate the lower bound for the area of this rectangle. So lower bound of the area of this rectangle. And we know that area of a rectangle, area of a rectangle formula equals to length times width. But since we are asked to use the lower bound unit for both the length and the width, so we are using the lower bound, which is lower bound of the length is 17.5, while the upper bound is 18.5. Assuming we are used to use, we are asked to use the upper bound, we are going to use 18.5. But since we are looking for the area of the lower bound, we are using 17.5 for the length, so which is 17.5 centimeter multiplied by the lower bound unit of the what? of the width, which is 5 centimeters. So multiply by 5 centimeter. So multiply 17.5 by 5 centimeter, give us 87.5 centimeter square. So this is the lower bound for the area of the rectangle. I think this one is meant to. So thank you. This is marked from the board. So the answer is 87.5 centimeter square. So that is question number 6. Then question 7 says, so question 7 says, while doing the physics practical, Adamo recorded the reading as 1.12 instead of 1.21 centimeter. Calculate the absolute error he committed. So if you look at the question, we have two values here. We have the estimated or recorded value, and we have the actual value. So the one of instead means the actual. So actual value is 1.21 centimeter, while the estimated or recorded value equals to 1.12 centimeter. Since we are looking for the error, we have 3 types of error. We have errors. So we have absolute error, we have relative error, and we have percentage error. So the one for absolute error is just the difference between the actual and estimated. So absolute error equals to actual minus estimated. So I mean actual value minus estimated value. So what is the actual value? 1.21. So we have 1.21 minus 1.12. So all in centimeter. So which is equals to 0.09. So 0.09 centimeter. So this is the absolute error value for this measurement. So the next one is question number 8. So this 0.09 is option 8. So let's move to the next question, which is question number 8. And question 8 says, so if you look at the information from question 7 and 8, we have the same information but different question. And what is the question there? The question is, what is its relative error? So the relative error formula equals to absolute error all over actual value. So what is the absolute error? Absolute error is from question 7. So question 7 is on absolute error, so which is 0.09 all over actual value. Actual value from question 7 is 1.21. So we are dividing 0.09 by 1.21. So this is just the relative error. So let me press my calculator. We have 0.09 divided by 1.21. Give us 0.074 38. So this is 5 decimal places. So which is approximately equals to 0.0744. That is to 4 decimal places. So that is option C. So that is that on question number 8. So question number 9. So if you check question 7, 8, 9, they have the same information but with different questions. So question 9 says, while doing his physics practical, Adamo recorded a reading as 1.12 instead of 1.21. So we are still taking reference to question 7, so which is actual value, the actual value there is 1.21, while the estimated value is 1.12. So in this case, in the case of question 9, we are asked to calculate the percentage error in this measurement. So the percentage error formula, percentage error formula is given as or relative error. Let me just use that. Relative error multiplied by 100. So percent. So this is just the relative and percentage error formula. So if you now check question 8, question 8 is on relative error. And what's the answer to relative error? That is 0.07438. So we are taking that answer, which is our relative error, that is 0.07438. Then multiply by what? 100%. So we have 7.438%. So to 2 decimal places, as the question from the question we are asked to correct the answer to 2 decimal places. So 2 decimal places of this will be 7.44%. So that is answer to question number 9. Question number 10. Question 10 says, if the percentage error of a student during a physics test is 0.05%. So the percentage error was given here. So percentage error equals to 0.05%. And the actual measurement is 25. So we are given actual value to be 25 centimeters. Then calculate the recorded measurement. If the recorded measurement is less than recorded measurement, so we don't have estimated or recorded measurement. Recorded measurement of value. So let me say recorded measurement is X, which is unknown. But according to the question, recorded measurement is less than, which means actual is greater than recorded X. So in this case, we are using the percentage error formula. Percentage error equals to actual minus recorded all over actual multiplied by 100%. So in this case, percentage error is 0.05, which is actual is 25 minus recorded measurement X all over 25 multiplied by 100 over 1. So the next thing to do is to look for a way of making X the subject of formula. And to do that, you can first divide both sides by what? 100. So if you divide both sides by 100, we have the 0.05 all over 100 equals to 25 minus X all over 25 multiplied by 100 over 100. So 100 over 100, we are left with 1. So we are left with 100 into, if you cross multiply, into 25 minus X equals to 25 multiplied by 0.05. So 100 multiplied by 25 is 25, 2,500 minus 100 times X, 100X equals to 25 times 0.05 is 1.25. So 1.25. So after that we collect like that. We now have 2,500 minus 1.25 equals to 100x. So 2,500 minus 1.25 gives us 22.49. I mean 2.49.
2.498.
2,498.75 equals to 100x. So the next thing to do is to divide both sides by 100. So 100. So this called is 1. We are left with x equals 24.9875. But we are corrected to 2 decimal places, which is recorded measurement or recorded value, which is equal to x is equal to 24.99 centimeter, which is option C. 11 says a piece of cloth was measured as 6.10 meters. If the actual length of the cloth is 6.35, so the actual length is A, which is 6.35 centimeter, but it was measured as 6.1 meters. So it was measured as, that is measured length, which is F equals to 6.10 meters. Then the question asks is find the percentage error correct to two decimal places. So the percentage error is from not. Now what's the percentage error formula? Percentage error formula is equals to actual measurement minus measured length all over actual length multiplied by 100%. So actual length is 6.35. So we have 6.35 minus 6.10 all over 6.35 multiplied by 100%. So which is equals to, so we have 5, we have 2.0. That's 0.25 all over 6.35 multiplied by 100%. So which is equals to, so 0.25 divided by 6.35. So we have 0.03937 multiplied by 100%. So which is us 3.9370%. So to two decimal places, it's going to be 3.94%. So which is option A. So that's answer to question number 11. So we move to question 12. Question 12 says the speed of light is known to be approximately 299,792,458 meters per second. If a nail measurement determines the speed of light as, so the actual length in this case is the first value given, which is 299 million. So the actual speed equals 299,792,458 meter per second. While the estimated speed equals 300 million and 1,200 meter per second. So we are asked to calculate the absolute error and the relative error. So we are using this question to solve for absolute error. So absolute error is difference between the actual and the estimated. So if you look at this, we observe that the estimated is more than the actual. So we are writing estimated first because if you check your option, we don't have negative values there. So we have E, which is estimated minus actual. So which is equals to 300 million and 1,200 minus 299,792,408 meter per second. So which is equals to 208 million. So if you do your calculation very well, we have 208,742 meter per second. So that is absolute error. While the relative error will now be relative error, which is also part of the question 12. relative error will be absolute error all over actual speed. And what is absolute error? That is 208,742 all over actual speed. That is 299,792,458 meter per second. So when you divide that, we have 208,742 divided by 299,79458, which is equal to okay, we are going to multiply this. Just divide. We have 0.1. Okay, what is the relative error as percentage? As percentage will be multiplied by relative error as percentage multiplied by 100. So multiply by 100. So which is equals to 0.0006963. So multiply by 100%. We have multiply by 100. We have 0.06963. But the question says, okay, if you check your options, we have the answer in 2 decimal places. So it's going to be 0.07%. That is to 2 decimal places. So the correct option in question 12 is option B. The actual an experiment yield a measured value of 28.6. So this is question 14. Measured value was given as 28.6 grams for a substance mass. If the percentage error is 5%, calculate the actual mass of the substance. So actual value is unknown. Percentage error is 5%. Percentage error formula is actual minus measured over actual multiplied by 100. So percentage error 5 equals S minus S is the actual, which is unknown, minus 28.6, which is the measured divided by X multiplied by 100. So we have 5 over 100. Why do we get 5 over 100? With 5 goes side by what? By 100. So we have 5 over 100 equals to S minus 28.6 all X. Then we have to cross multiply. So if we cross multiply, we have 100 into S minus 28.6 equals 5x. That is 5 times x. So 100x, 100 times 20.6 gives us 2,860 equals to 5x. Then you collect the like 10. You have 100x minus 5x equals 28560. So 100 minus 5x, which is 2860. If I put 7 by 95, we have x equals to 30.1 grams, which is option A. Then the next question, which is the last question, the question says an electronics device is advertised to have a power output of 50 watts. So the actual watt or the actual power, that's number 15, actual power is given as 50 watts with a possible percentage error of 5%. So percentage error equals to 5%. What is the absolute error in the power output measurement? So before we get our absolute error, we must first look for measured power. Absolute error is unknown. Let me call this y. Y the measured or estimated measured power is given as x. So to get the measured power, we are going to have percentage error equals to actual minus measured over actual multiplied by 100. So percentage error is 5%. which is actual. That is 50 minus x all over 50 multiplied by 100 over 1. So if we divide both sides by 100, we have 5 over 100 equals 50 minus x over 50. So if we cross multiply, we have 100 into 50 minus x equals 5 times 50. So we have 5,000 minus 100x equals 250. That's 250. Then the next thing is to correct like that. 5,000 minus 250 equals 100x. So we have x equals 5,000 minus 250. That is 4,750. So 4,750 divided by 100. We have a 0.0, that is 47.5. 47.5 watts. But the question says the absolute error. Absolute error will now be difference between the two measurements. That is actual minus estimated or measured. So which is 50 minus 47.5. So 50 minus 47.5 is 2.5. So 2.5 watts. So that is the absolute error. So thank you. So if you have difficulties in any of the solutions, you can reach out to us. So thank you.